Hello and Assalamualaikum. So today we'll be going through some of the more advanced techniques for inverse Laplace transform. Okay, so in our previous lecture we have seen how we can apply inverse Laplace transform to solve differential equations. But that was quite basic. Today we'll go through some examples where there are slightly more advanced techniques. Okay, so the main one that we want to focus today is you have learned about the first shift theorem. So according to the first shift theorem that we have done before, if we have a function ft and we apply Laplace transform to that, we get fs. But if we have the same function with EAT, then our function has now been shifted by A. S has been shifted by A in the transform version. Okay, so we will use this to perform inverse Laplace transform in the opposite direction. So here we will look at some examples. Let's do the first one. So we have the s minus 6, s minus 1 squared plus 4, and they ask you to find the inverse of that. So from here we need to change the shape of the fs into a form that you can inverse directly, and it seems like one way to do that is to change it into this form. So then you can put it as this. Okay, and over here you can see that the one on the left looks like it should be able to be inverted using the cos omega t function with the first shift theorem, and on the right side it seems like you can change the numerator and then use the inverse Laplace of the sine omega t with the first shift theorem. Okay, so this one is effectively, we'll just put this as it is. And then this one, you bring out the 5 and you put it over 5 over 2 because you want the inside numerator to be 2. See? So now the one on the right side has become something you can inverse with the sine function. So this will become without the first shift, this would become a cos function, cos 2t, but because there's a shift on the with the s here, we use a is 1, so et cos 2t. Then on this side we have 5 over 2, this is sine 2t but with the shift there, it's et sine 2t. Okay, so this is the first example of how we can use the first shift theorem to help with the inverse Laplace transform. Basically, you need to match up the numerator with a matching denominator if you want to follow the rules for inverse Laplace transform using cos and sine omega t. Okay, so that's quite straightforward. Let's look at the second example. In the second example, we have we need to find the inverse Laplace of 15 over s squared plus 4s plus 29. Okay, so when you look at this, normally what we usually do is we try to factorize the denominator, and then we might need to use partial fractions to find the a and b, and then use inverse Laplace on that. But in this example, you cannot really factorize the denominator into whole numbers, okay, integers. So you need to fix that. So one way to fix that is we can rearrange the denominator so it looks like this. So we have broken 29 into 25 and 4, and we have factorized the 4 to become s plus 2 squared, and then the 25 we leave as is, and then in this form we can see that we can break this further into 3, 5 s plus 2 squared plus 25. Okay, so when you do the inverse Laplace of this, so we get 3 minus 1 5 over s plus 2 squared plus 25. So you can already see that this is becoming a sine problem. Okay, sine of 5t, but with a phase shift of e minus 2t. Okay, so working backwards using the first shift theorem. This is how you get the answer. Okay, so let's look at our next example. We need to find the inverse of s plus 7, s squared plus 2s plus 5. So here is a problem similar to the first one. You cannot really factorize the denominator, so you need to find a clever way. You need to be clever on how you can use the first shift theorem to factorize the denominator. Okay, it can actually be rearranged into this form. Okay, and then this can be further, because the denominator and the numerator has to have s plus 1 for it to change it to a cos function. So we can rearrange the same equation into this form. Okay, So the one on the left, we can already use the inverse using the cos omega t with the first shift, and we need to adjust the numerator for the second one. So we can do that by this one, we say like this, stays like this. Okay. So from here you can directly use the same sine, cos and sine. Okay, so this is a cos 2t with first shift theorem of e minus t, and this is a 3 sine 2t with the first shift theorem with the first shift of 11 e minus t. Yeah. So it's very important when you get this kind of problem, you must try your best to find a way to factorize it in such a way that you can inverse using the sine and cos functions. Sine and cos inverse Laplace, yeah. So this can only come to you naturally when you do more practice on your own. Okay, so now we look at something more challenging. I think we'll start with hold on. Okay. So this is our next example, example 4. So for example 4, we have this more complicated question. We need to find the inverse Laplace of 4s squared s plus 1 s plus 2. Okay, so you need to go through the rules of partial fractions. Okay, normally we just did just elements in brackets s plus 1 s plus 2, so that one you can break directly into a and b. But in this case, where there is a repetition of the s, we need to break it into 4 parts. We have a over s, b over s squared, c over s plus 1, d over s plus 2. Okay, so with this method, you can use the long way of multiplying every a, b, c, and d with the denominators of the others to get the same denominator. Okay, but there is also a shortcut that you can use to help with the process, and that is to set s so as to make the denominator equals to 0. Okay, so for the first example, we know that if we set s equals to 0, this will be 0. Oh, sorry. This will be 0, and everything will be 0 for over infinity. Okay, so let's see what happens. But first we do need to first expand it first. Okay, so let's do the expansion. So to get the same denominator, a will have to be multiplied with s plus 1. Sorry, s first. S plus 1, s plus 2. B needs to be multiplied with s plus 1, s plus 2, and c needs to be multiplied with s squared, s plus 2, and d needs to be multiplied with s squared, s plus 1. So all of this will be over this. Okay, so from here, this is what I said, we can try to change of s where the numerator is 0. So if we set s equals to 0, what happens to the numerator? The numerator will be 0, and then on the top we have a 0, 1, 2 plus b 1, 2 plus c 0, 2 plus d 0. So this will be equal to, look at where it's on the left hand side, is 4. So it's equals to 4. So all that, because a times with 0 is 0, c times with 0 is 0, d times 0 is 0, all we have is 2b is equals to 4. Therefore b is equals to 2. Okay, so that's the first value that we have. Next we can set s equals to minus 1, because minus 1 plus 1 here will make the numerator 0. So if you set it as s minus 1, let's see what happens. So then a minus 1, 0, 1, b 0, 1 plus c 1, 1 plus d minus this one becomes 1, and this one becomes 0, equals to 4. So a times 0 is 0, b times 0 is 0, c is equals to 4. Okay, so now we set the next value. We set it equals to negative 2. So if it's negative 2, this one becomes a negative 2, negative 1, 0 plus b negative 1, 0 plus c. This one becomes 4, and then 0, and lastly d becomes 1, becomes 4, and negative 1 equals to 4. So from here all that's left is negative 4d is equals to 4, and d is equals to minus 1. So you see here we already have b, c and d. We just need to find a. Okay, and to find a, we need to expand this equation here. Okay, so when we expand it, we will get this. Okay, as cubed plus 2as plus 2a squared 2as bs squared plus 3bs plus 2b plus cs cubed plus 2cs squared plus ds cubed plus ds squared. This will be equals to 4. So we can then group it according to the order of S. So we have A plus C S cubed, and then we have plus 2A plus B plus 2C plus D for the S squared, and we have 2A plus 3B oh, I missed the D here. Never mind, we're not using this anyway, but let's put it there. Okay, so all that's left is so this is S, and 2B equals to 4. So we will be using this one to find A, yeah? Because we know on the left hand side there is no value of S. Therefore 2A plus 3B must be equal to 0, and we know that this is equal to negative 3B. A is equal to negative 3B over 2, and B is 2. So it must be equals to negative 3. Okay, so now we have the values of A, B, C, and D. Now we can finally put it in the full partial fractions equation, which is 4 over S squared, S plus 1, S plus 2 is equals to A over S, and A just now is negative 3, so negative 3 over S, plus B is 2 over S squared, C is 4, S plus 1, and D is minus 1. D is minus 1 over S plus 2. Then you do the inverse for all of these. So the first one you get negative 3. The second one you'll get 2t. This one you'll get 4e minus t. And lastly you'll get e negative 2t. Okay, once you have it in the form of these partial fractions, it becomes quite easy because you can just use the inverse directly from the table. The real challenge here is to find ABCD, and we use it by first expanding everything. Once you have expanded, you can use this method to directly find sum of the values, okay, B, C, and D. But you don't get A with this method, so you need to further expand the equation just now, and then use the knowledge that you have about the other equations, the other values, the B, C, and D's, to find what A is. Okay, so it's a combination of two methods, okay, to find the answer that you want. So let's go to our next example. So this one, it looks like this. We need to find inverse Laplace of s squared plus 9. Okay. So this one is quite similar to the one just now. First you need to break it into partial fractions. But this one looks different a bit because we have a quadratic root at the bottom. Okay, and you cannot factorize it without using a real number. Okay, with using a real number you need to use a negative, right? Imaginary number, so we don't use that. So when you want to use partial fractions and there is a quadratic root in the denominator, you need to change your numerator like this. Okay, so same as just now, we need to multiply up everything to get the same denominator for all of them. Okay, this will be over s squared plus 9. Okay, we can use the same technique as now to help find some of the values. We can set s equals to 0. Okay, if s is equals to 0, then a 0 9 plus b 9 plus 0 plus basically 0. Okay, and this will be equal to what is on the other side, s plus 1 so we set this as 1. So we have b is equals to 9b is equals to 1, so b is equals to 1 over 9. Okay, so we only get b through this method because we cannot put negative 9 as s, okay, because it's s is s squared here. So you need to do the full expansion again. Of this equation. So when you expand that, you'll get as cubed 9as bs squared plus 9b plus cs cubed plus ds squared over s squared plus 9. Okay, so we can see here that for the s cubed, a plus c, okay, must be equal to 0 because there's no s cubed on the other side of the equation. And then we also have b plus, for the s squared we have b plus d equals to 0 because there's no s squared also. And from here we know what b is, so we can know directly that d is minus b, negative 1 over 9. Okay, so now we have two values that we have. And then for the s, we have 9as. Okay, on the other side we have 1s, so a must be 9a over equals to 1, so a is 1 over 9. And just now from here, from 2 we know that C is minus A, which is minus 1 over 9. Okay, so now we have values for all of them, A, B, C, and D. We can put it back into the equation. We will have, we can say that S plus 1 over S squared plus 9 is equals to 1 over 9S plus 1 over 9S squared minus 1 over 9 S plus 1 S squared plus 9. Okay, because C is minus 1 over 9 and D is minus 1 over 9. Okay, you can break this further into this form, 1 over 9S squared negative 1 over 9 S over S squared plus 9 and negative 1 over 9 1 over S squared plus 9. So you can apply Laplace, inverse Laplace directly. Negative 1 over 9 plus S over S squared plus 9 Laplace 1 over S squared plus 9. That will give you the answer of 1 over 9 plus T over 9 minus cos 3T over 9 and minus sin 3T over 9. Okay, so you need to do a lot of practice of partial fractions because sometimes it can get confusing on, do you have A, B, C, D separate, or is it A, B, C, A, B, and then C, S plus D because of the quadratic in this form. Okay, so this one you have on the top, you have C, S plus D. Okay. Okay, so this we're going to do the last question now. Just the longest question we have. So this is our last example. What was it? Six, yeah. Okay. So example 6. It looks like this. Okay. So similar to previously, because there's a S plus 1 squared, okay, that means there's a repetition in the roots. So we can write this as A over S plus 1 B over S plus 1 squared, similar to just now when we had S squared S1 at the numerator. And then this one we have, because it's quadratic, we have CS plus D over S squared plus 4. Okay, so we do the normal thing first. We have to multiply up. Okay, this one is S squared plus 4 CS plus D and S plus 1 squared. S plus 1 squared. squared plus 4. Okay, so then we find what we can by setting the set s equals to -1 to get the denominator to be 0. So if s is -1, then a 0, it doesn't matter like the rest, and then b becomes 5, and then c and d becomes 0 lah, so it just becomes 0. And on the other side we have 1, so we know that b is equals to 5b is equals to 1, b is 1 over 5. That's one thing we already have. Okay, now that we have b is equals to 1 over 5, and we cannot use it as minus 4 because it's a square root, squared. So we need to expand what we have just now to find the rest. Okay, we take to expand this equation. So once you expand, you will get this. Okay, it's quite long, this one. So a plus c s cubed plus a plus b plus 2c plus d s squared. Then we get 4a plus c plus 2d s, and we have plus 4a plus 4b plus d is equals to one, right? Okay, so from this we can make 4 equations. First equation is that a plus c is equals to 0, a plus b plus 2c plus d is equals to 0, 4a plus c plus 2d is equals to 0, 4a plus 4b plus d is equals to 1. Okay. So from let's put this one as 2, 3, 4, 5. So from 2 we know that a is equals to minus c. Okay, and then from 4 we know that 4a plus c plus 2d is equal to 0, and then we know that 4 minus c, a is minus c, so plus c plus 2d is equal to 0. So you have negative 3c plus 2d is equal to 0, 2d is equals to 3c, d is equals to 3 over 2c. Okay, so we put this as number 6. So we put 6 into 5. And then we will get 4 negative c plus 4b plus d is now 3 over 2c equals to 1. And that will give us negative 5 over 2c plus 4b equals to 1. Okay, so that means c is one minus okay, so that means hold on, negative 5 over 2c plus 4b, b just now is 1 over 5, equals to 1. So when you calculate this, you'll get c is equals to, so negative 5 over 2c, okay, 1 minus 4 over 5 is equals to 1 over 5. C is equals to 1 over 5 times negative 2 over 5. You get negative 2 over 25. That's your C. Okay. And then we can find D by using equation 6. Put C into 6. And we get D is equals to 3 over 2c equals to, and c is 3 over 2, negative 2 over 25, negative 3 over 25. Okay, so you have everything now, and you know what, that a is the a is negative c, which means a is equals to 2 over 25. Okay, so now you have all of the a, b, c, and d's. You just have to rearrange them into the final form. So now we have need to find the inverse Laplace of a is 2 over 25, 1 over s plus 1, plus 1 over 5, 1 over s plus 1 squared, plus 1 over 25, 2s plus 3, s squared plus 4. Oh, I forgot to put the inverse here. Inverse. And this is minus as well. 1 over 25, 2s plus 3, s squared plus 4. And then this will give you 25 e minus t, 1 over 5 t e minus t minus 2 over 25 cos 2t, and lastly negative 3 over 50 sine 2t. So once you have the ABCDs, each of the numerators can be easily changed. Using the inverse Laplace to find the table directly. Okay. So for this question, for this example, there's a lot of calculation and it's very easy to make a mistake if you're not careful. Okay, the toughest part I think here is to now that you have these four equations, knowing which one to use to find the value that you want. Okay, that one takes practice as well. We only have B from ABCD, so you need to manipulate these four equations and rearrange them to get the other values. Okay, so that's all for today. I hope you go through this by yourself. Try and do these questions by yourself and only check these notes when you are stuck. Okay, so that's it from me for now. All the best. Thanks.